You're sitting at the edge of fire. Somewhere in Africa, 70,000 years ago, the sky is black. The savanna is silent except for insects and distant wind. Around you, your tribe settles in for the night. Maybe 40 people. The only 40 people you have ever known. The only 40 people you will ever know. You have memorized every face, every scar, every laugh. You know exactly what each person looks like in firelight. And then someone sits down across the fire from you, and you cannot look away. Her skin is white, not light, not pale. White euro, like ash, like bone, like the inside of shell no one has ever opened. Her hair falls in silver waves past her shoulders. Her eyes catch the firelight, and something is wrong with them. One is brown, the other is blue, and she's looking directly at you with both of them. No one in your tribe has ever looked like this. No one in any story the elders have ever told looks like this. You have no word for what you're seeing. You have no framework for it. Your brain is trying to process a human being who looks like something between your world and a dream. She reaches out and picks up a piece of flint with her left hand, and she begins to work it, faster than anyone you have seen, better than anyone you have seen. Her eyes track something in the stone that no one else can see. And in the space of a few minutes, she produces a blade so precise it looks like it was made by something other than human hands. You sit there in the firelight, heart racing, completely dumbfounded, and you ask yourself, hey, Euro, does a person like this actually exist? Statistically, yes. But that raises a more interesting question. Out of every human being who has ever lived across the entire span of human prehistory, Euro, across hundreds of thousands of years and billions of lives, Euro, what would the single rarest possible ancient human actually look like? What combination of traits would make one person so statistically improbable that they would be unlike any human who came before or after them? To answer that, we need to break humanity down, trait by trait, probability by probability. And by the end of this video, you will understand exactly how impossibly rare a single human life can become. Let us start with where our person comes from. For most of human prehistory, our species lived in small, isolated bands scattered across Africa. Genetic studies, including landmark research by Dr. Sarah Tishkoff at the University of Pennsylvania, have shown that certain African lineages represent the oldest continuously existing human populations on Earth. But 70,000 years ago, something catastrophic happened. The Toba supervolcano in what is now Indonesia erupted with a force so massive it triggered a global volcanic winter. Crops died, animals vanished, and the human population, already small, collapsed. Some researchers estimate the entire human population on Earth dropped to as few as 10,000 surviving individuals. Some bands may have numbered fewer than 40 people, separated by hundreds of miles of hostile terrain, each one its own tiny island of humanity clinging to existence. We place our person in one of these bands, a group of perhaps 40 individuals, one of roughly 200 such groups alive on the entire planet at that moment. That gives us a total human population of around 8,000 people. Our person is already one in 8,000 just by existing at this precise moment in this precise group. But we are only just beginning. Now we give her albinism. In the modern world, albinism is rare. Among African populations, it occurs in roughly 1 in 5,000 births. But in the ancient world, albinism was not just rare. It was nearly a death sentence written into the skin at birth. Albinism is caused by mutations in the genes responsible for melanin production, euro, the pigment that gives skin, hair, and eyes their color. In someone with complete albinism, this production is absent or nearly so. The result is white or near white skin, silver or pale yellow hair, and eyes ranging from pale blue to near pink, depending on how light hits them. Under the equatorial African sun, unprotected skin burns fast and repeatedly. Vision impairment comes with the condition, making hunting and navigation harder. And in a world where standing out from your group meant attracting predators, being the one person in your tribe who looked like a ghost in the firelight was not an advantage. For an ancient human with albinism to survive infancy, survive childhood, survive the predators and the sun and the social complexity of tribal life long enough to be counted as a living adult euro, we estimate that probability at roughly 1 in 15,000. Our running probability is now 1 in 120 million. But we are not finished. Now we make her left-handed. Left-handedness has existed throughout human history. Archaeological analysis of ancient stone tools and cave paintings euro, including research by Dr. Natalie Uomini at the Max Planck Institute for the Science of Human History euro, confirms that roughly 10% of humans across all eras have been left-handed. But in ancient tribal life, being left-handed carried a real social cost. Every tool was made for a right-handed grip. Every shared task assumed a right-handed partner. And in many ancient cultures, the left hand was associated with the unclean, the unlucky, the other. A left-handed individual in an ancient band was subtly but constantly disadvantaged. We estimate that left-handed individuals who survived to full adult social integration in ancient communities represented closer to 1 in 15 rather than 1 in 10. Our probability is now 1 in 1.8 billion. Now we go deeper. Our person has heterochromia, two completely different colored eyes. You already saw it in that firelight. One brown, one blue. Heterochromia occurs when the two irises carry different concentrations of melanin the same pigment, or lack of it, that defines her skin and hair. In modern populations, complete heterochromia affects roughly 1 in 1,000 people. But in an ancient isolated band with very little genetic diversity, rare mutations like this would have been far less common. We estimate the probability of complete heterochromia in an ancient individual at 1 in 5,000. We are now at 1 in 9 trillion. Pause on that number. And we still haven't explored the even rarer traits. Maybe that's a story for another time.